Okay, this is lesson 6.4, and we are talking about dilations. A dilation is the last type of transformation that we're going to talk about in this chapter, and that's when you make something bigger or smaller. So I could start off big, like this big smiley face, and I could create a small smiley face. And vice versa, I could start with a small and make it big or medium or whatever. So making some things bigger or smaller would be dilations. If you could just read this question and see if you can answer it. What happens when your eyes dilate? Hopefully you know that means to get bigger or smaller, but usually we talk about eyes dilating, they get bigger. So that's what we're doing today, making things bigger or smaller. Just read this for now and make sure we understand the words, okay, for dilation. Any figure can be dilated by a scale factor called K. Sometimes they call it other letters, but we're going to call it K. So our scale factor is what we're going to make bigger or smaller, make our point bigger or smaller by. If you look at the symbols, okay, here's our original XY. Whatever K is, you're going to multiply it to each piece. Okay, and that's going to give you your next piece, your image. All right, when we have K being a whole number, meaning bigger than 1, we're going to enlarge it or make it bigger. Okay, so if you have a whole number, like say we start with the number 2 and we multiply it by a whole number, like use 3 for example, we're going to make this bigger, right? This becomes a bigger number. From 2 to 6, we got bigger. All right, for this example, if we have K being a fraction that's smaller than 1 or a decimal that's smaller than 1, we're reducing. So start off with my same 2, multiply it by a fraction or a decimal. Let's multiply it by 0.5. We're going to get something smaller. Okay? So that's what we're doing here, making things bigger or smaller depending on what K is. All right, this is what we're going to write down on your graphic organizer, your yellow sheet. Go down to where you see dilations. Okay, here it is, dilations. I have no words to add here, but we are going to highlight. A dilation resizes the shape. So it maintains the shape and the measure of the angles. So the angles are still the same, but the actual size changes. So I'm going to highlight that, changes the size. Okay, so very important to realize that this is the only one that doesn't stay the same size. This is the only one that's not congruent. So please write that down. And you're going to write down the other things that I have here. I'll highlight them for you. I crossed off this. Okay, so cross that off and then write down these things. Your scale factor is K, and here's your rule. I want that written down. Okay, pause the video. Hit play when you're ready. Let's look at this example, just looking for now, and then we'll do an example together on your packet. So first, just looking. We have triangle ABC is dilated by a factor of 2. So find ABC, figure out which color is ABC. Hopefully you found that ABC was the blue triangle here. And that has a name. The beginning piece is called the pre-image. Right here, the pre-image is our blue triangle. And the image is going to therefore be our green triangle. And we also know that because the green has the primes. Okay? A prime is there too. So they have the primes. So, all right, so what we're going to do is write down the coordinates of ABC. So I did that right here. Those are the coordinates of triangle ABC. And if we want to dilate by a factor of 2, what we're doing is going to multiply each piece by 2. So 2 times x and then 2 times y. So if I show that here, A, instead of 1, 1, we're going to multiply each piece by 2, and we get A prime to be 2, 2. I'm just multiplying 1 times 2 and this 1 times 2 to get 2, 2. So here, B, we start off at 1, 4. I'm multiplying both of those things by 2. 2 times 1 and 2 times 4. So that gives me 2, 8. See if you can figure out what C will be. Original is 2 and 1. I'm going to multiply each of them by 2, and I get 4, 2. All right, 6.4 practice. This is in your packet. Let's do this right now, please. We are on the very last page, and it says to find the coordinates of the vertices of each figure after a dilation with the given scale factor k. Then graph the original image and the dilation. Well, the original is already there. So what we need to do is write down our coordinates. Actually, it's already given to us, our coordinates of the original. Okay, so my new coordinates, I'm going to put S prime here, U prime, and N prime. Okay, and my K, this is the important part right here, K is 4. That means I want to multiply X and Y by 4. Okay, so let's start off with the first one, S. If you multiply 4 times -2, I'm going to get -8. And 4 times -1, or excuse me, +1, 4 times 1 is 4. Okay, let's look at this one. I'll do it in a different color just in case it helps you. Okay, we have U here, and it's going to become U prime here. We're going to multiply each of those by 4. Well, 0 times 4 is still 0, and 1 times 4 is 4. All right, and then let's do pink. N is here. It's going to end up over here. All right, -1 times 4 is -4. And obviously, we have another -4 here. And all you need to do is plot those points. So let's start with S prime. We have -8, 4. So -8 on the x-axis. 8 and 4. Okay, there's my S prime. U prime is at 0, 4. And N prime is at -4, -4. So it should still be a triangle looking similar to this. We call it similar because it has the same angles. So the shape looks the same, it's just a different size. Okay, so if we connect our dots, it should be the same shape, just made bigger. All right, let's do number 2. They already give us MATH. Okay, this is math. So M prime, A prime, T prime, and of course H prime. Well, to get our primes, I need to multiply times 1/2. Let me explain one thing first that might help you. If I were to multiply a number times 1/2, let's just pick a number for a second. You don't have to write this down, just pay attention. If I were to multiply 4 times 1/2, well, what would you do? I would write this as 4 over 1 times 1 over 2. I'm not changing anything. I just put a 1 underneath the 4 that kept it the same. And I multiply across the top. 4 times 1 is 4. Multiply across the bottom. 1 times 2 is 2. So multiplying 4 times 1/2 is the same as 4 divided by 2. Right? 4 divided by 2. So really, if I am multiplying by 1/2, it's the same as dividing by 2. So each one of these vertices, I'm going to divide by 2. Get out your calculators and get ready. I'll do it in a different color so it's easier to see here. So M prime, let's see. Starting at -3. What's -3 divided by 2? You can do it on your calculator. -3 divided by 2. That's -1.5. And 1 divided by 2 is 1/2 or 0.5. don't care if you write them as fractions or decimals, either way is fine. Okay, let's do this one. All right, 1 divided by 2 is 1/2, or 0.5. 3 divided by 2 is 1.5, or 1.5, or 3/2. This one's easier, t. 2 divided by 2 is 1. -2 divided by 2 is -1. And h isn't bad either. -4 divided by 2 is -2, and -2 divided by 2 is -1. So if I were to plot those points, I'll do them in red. Let's see, m is -1.5. So I'm going, here's -1 on the x-axis, sort of, and here's -2. I want somewhere in between there. So I really want to go here and then go up to 0.5. So this one's a pain in the butt to graph because of the halves, but this, I'm going to try to get it right in the middle of that box should be your -1.5, comma 0.5. -1.5 and a half. Okay, that's your m prime. A prime is at 1/2, so here's the x as 1/2, and then I want to go up to 1.5, which is right here. Where do they meet? They meet right there. So I'm going to erase that just to have my one dot right there. Okay, we're plotting halves. Those ones were hard. T and H are going to be easy, so let's A prime. T prime, 1, -1, that's easy. And H prime, -2, -1. That one's easy too. Okay, don't get confused with the halves. Okay, so it's the same shape, it's just smaller since I multiplied by a fraction. I want you to take a minute now and try numbers 3 and 4. Pause the video and play when you've done that. All right, so I have f is at -2, 1, so f prime, when I multiply by 2, I will get -4, 2. U prime, -2, 4. N prime, 6, 2. I just multiplied everything by 2. And when I graph that, it's just a little bit above. It's just the same shape, but bigger. Okay. Number 4, if you haven't tried it already, you understand that multiplying by 1/4 is the same as dividing by 4. So if you need a second, you can pause again. So if I divide everything by 4, P prime, I get -1, 1/2. If you read it like this is fine too. 0.5 is the same as 1/2. Okay. Again, 0.5 would be okay for that 1/2 and for the L prime. And A prime as well. And that would be a -0.5 for the Y prime. Okay. And I'm going to plot those. Don't get too frustrated with the halves. I know that it's trickier to graph, but just get the idea of how we do it. I think they'll be easier on Alex for you. Okay, now let's look at number 5. Rachel and her cousin Alina live in different cities that are about 100 miles apart. On a map, the two cities measure 5 inches apart. What is the scale factor? We're looking for what do you multiply by to get the map. Well, I start off at 100, right? And I'm going to multiply it times something to get my map, which is 5. Let me write that out more like an equation. 100 times some number that we don't know, call it x, equals 5. How would you solve for x? Well, if it were me, I would get x by itself by dividing by 100. Whatever you do to one side, you do it to the other. And 5 divided by 100, well, you could make it a decimal. Or, let's write this here, x equals 5 over 100. We could just reduce this fraction, would be even better. Let's reduce. Let's divide by 5. Notice the smaller numbers on the top. In the end, when I reduce, the smaller number should still be on the top. Some people flip them for some reason. I still don't get that. So 5 divided by 5 is 1. 100 divided by 5 is 20. Okay? Or just do 5 divided by 100 and get your decimal. All right, number 6. A square has vertices JUMP. I'm not going to read them. After a dilation, the new square jump has vertices. It should say J prime, U prime, M prime, P prime. What is the scale factor? Same question. And I drew this, if you could draw this stuff right here, these two things, with a little arrow. If I am going from, erase my arrow, from the top to the bottom, you'll notice that each one is getting smaller. So I know that I'm going to be dividing by something or multiplying by a fraction. Okay? So what I can do is say, well, what do I have to multiply one number by to get the next number? If you don't want to use decimals, just pick ones that don't have decimals. Let's use this one right here. Okay? What do I have to multiply 4 by? I don't know that number to get 2. Okay? What do I multiply 4 by to get 2? Let's see. Let's divide by 4 to solve for x. X equals 2/4, or make it a simplified fraction. We'll divide by 2 and get 1/2. And you can see that that works for everything. And of course, this also means divide by 2. All right. Let's see. If I go to this one, to get to this one, do I divide by 2? Is 2.5 half of 5? Sure it is. Okay, what's half of -1? It's -1/2. It works. So the answer is 1/2, or divide by 2. Okay, last one. This one's a little tricky. We have a landscape designer has a drawing of a flower bed that measures 6 inches by 9 inches. So if you would draw a rectangle and label the bigger side 9 and the smaller side 6, that's what the landscape designer has. Okay, now the owner wants an actual flower bed to be 5 by 7.5. So let's make the smaller side 5 and the bigger side 7.5. What is the scale factor? So we are going from this to this, or from this to that. Either way. I don't care which one you use. You can use anything you want. We can use the one that doesn't have a decimal if that helps people. Let's say, what do we multiply 6 by? We don't know. Something, x, to get 5. Well, how do we solve for x? Divide by 6. Reduce it if you can, but this one can't be reduced. So there you go. Scale factor is 5/6. And we can check ourselves. Here we go, let's check. Okay, let's take 9 and multiply it by our scale factor, 5/6. 9 times 5 divided by 6 on your calculator comes out to 7.5, which is what I want. Right, 9 to 7.5. All right, check Google Classroom for the homework.